Hi, future doctors. Welcome to the next class. In this class, we will discuss one shot about magnetism and matter. According to rationalized textbook, new textbook, which portion is going to be available for final NEET exam? So only from that portion, we are going to discuss how they may ask the questions. I will try to give maximum information in minimum time. So magnetism and matter. So any substance is going to be calling as magnet when it is going to attract another substances. So whenever properties of the magnet, any magnet is going to be suspended on the surface of the earth, it will be coming to rest always in the direction of north and south pole of the earth. Geographical north and geographical south pole of the earth. The end which is showing towards geographical north is called north pole. The end which is showing geographical south is called south pole. So this property, wherever you are suspending, always you will be getting magnet in the direction of north and south. We will use compass needle to know the directions. So in that compass needle also one small magnet is going to be present. So it will be coming always in the direction of north and south. This is called directional property. If you divide this magnet into two parts, each and every part. So if you have taken here north pole, here you will get south pole. So in below part, if you have here south pole, here you will be having north pole. So if you divide again another part, if you have divided again another part, so each and every minute particle will be having both north pole and south pole. This property is called pair property of the magnet. Which property? Pair property. And another one also we are getting. So monopole, single poles do not exist. Monopoles do not exist. So this much information you are going to get. And always same poles always repel, opposite poles are always going to attract. So we came to know since our childhood. Now, what is the length of this magnet? Generally, if you are taking magnet, this is a rectangular bar. This is not magnet. So you have to mention both north pole and south pole. So where attractive power is more means at poles. Therefore, this one they will call pole strength. Generally, it is denoted by small m. So small m is nothing but pole strength. So the distance between two ends of the magnet is called geometric length. The distance between two poles of the magnet we will call magnetic length. Always magnetic length is less than geometric length because poles will be inside the magnet. Now, what is the relation between magnetic length and geometric length? So magnetic length is 5 by 6 times of geometric length. They will give geometric length for you. They will ask magnetic length. Geometric length L they will give, magnetic length 2A. 2A is equal to 5 by 6 times of L. This is the relation between magnetic length and geometric length. Next, small m we call here poles. Between these two poles, what is the attractive force or repulsive force means? That is given by similar to Coulomb's law, mu naught by 4 pi m1 m2 by r square. So this is given by force between two poles. So what is the dimension formula for mu naught they will ask. At that time, if you know pole strength, you are going to get. Now, what is the magnetic moment? What is the magnetic moment means? Like in electric charges fields, how we will define? Same like that. M is equal to pole strength, one of the pole strength into separation between these two poles. That is going to be M into 2A. What is the magnetic moment definition we came to know in moving charges and magnetism means NIA. So, unit for this is ampere meter square. Current unit ampere, area unit meter square. So you remembered maybe NIA. N is number of turns, I is current, A is area. Ampere meter square, 2A is length. Therefore, pole strength units 2A is L. L means meters. Ampere meter square. Pole strength into meters. So if you cancel, now pole strength unit, that is going to be ampere meter we are going to call. So from this you will get dimension formula for mu naught. So what is mu naught? One of the year they asked mu naught dimensional formula. 4 pi is constant, we don't want dimension formula. Fr square by m1 m2. So force dimension formula ml t power minus 2 L square pole strength ampere meter ampere meter. You can solve this. That is the dimension formula for mu naught. So what is the direction of magnetic moment here? So always magnetic field lines outside the magnet, it will be from north to south. Is it visible? Yes. From north to south. Inside the magnet, it is south to north. Always these are closed loops. Same like electric charges and fields. But those are open loops. These are closed loops. Outside the magnet direction, north to south. Inside the magnet direction, south to north. In magnetism means moving charges and magnetism also, we discuss what is the direction of magnetic moment. It is from south to north. South pole to north pole. Therefore, magnetic moment is a vector quantity. How this magnetic moment will be changing depending on cutting of the magnet. If you are taking two poles, now if you divide magnet parallel to its length, so length is going to be remaining same, 2a. Then pole strength is going to be dividing into equal halves. Therefore, new magnetic moment, so m by 2 into 2a. So because 2a is not changing. What is m into 2a? M into 2 is already m. Therefore, capital M by 2. New magnetic moment is going to be m by 2. What is the magnetic moment of each part now? M by 2, m by 2. So, what is the ratio of new pole strength and old pole strength? They will ask. New pole strength m dash is m by 2. Old pole strength is m. So, m dash by m is 1:2. If you cut this magnet parallel to its length, 2 times, parallel to its length 2 times like this. Now see how many parts it is going to become? It is going to be divided into 3 parts. Therefore, pole strength is going to become m by 3. Magnetic moment is also going to become m by 3. Next, if you cut this magnet perpendicular to its length, north pole, south pole. If you divide this magnet perpendicular to its length into 2 parts, then the length is going to become half. Now, new magnetic moment m dash equal to pole strength remains same. It is not divided. M into, but length divide half, 2a by 2. Now, what is again m into 2a? M into 2 is nothing but m by 2. So, magnetic moment remains m by 2 if you cut parallel to its length, perpendicular to its length. If you divide this magnet into 4 parts, so one is parallel to its length, one is perpendicular to its length. Then what is the magnetic moment of each part? So parallel, perpendicular. Therefore, total it is divided into 4 parts. Therefore, m by 4. Now, what happens to its pole strength? Now, pole strength is going to be m dash is going to be m by 2 because parallel to its length we cut only 1 times. If you cut parallel to its length, pole strength is going to be divided. If you cut perpendicular to its length, the length is going to be divided. So this is about how they are going to ask magnetic moment by cutting the magnet. Now see. Now this magnet result in magnetic moment. If two poles, south pole, north pole. So magnetic moment of this one is m1. So another magnet I am taking by same poles touching each other. South pole, north pole. This is m2, which is making an angle theta. So what is the resultant magnetic moment formula? M dash equal to root of m1 square plus m2 square plus 2m1 m2 cos theta when same poles touching each other. When opposite poles touching each other. So south pole, north pole. So north pole, south pole. Its direction will be like this. At the time, whenever opposite poles, root of m1 square plus m2 square minus 2m1 m2 cos theta. Whenever opposite poles touching each other. So on this they asked last year one question, isn't it? What is that question means? A magnet is going to be divided North pole, south pole, it is bent at its center by making an angle. So by making an angle 60 degrees. So at its center, if it is making 60 degrees, here which poles will be available? Here south is there means here north is available. Here north is there means south pole. Therefore, opposite poles you have to use. So at center means this is going to be m by 2, this is going to be m by 2. So m dash is root, so m by 2 whole square plus m by 2 whole square minus 2m by 2, m by 2 cos 60. So you have to solve this. That is going to be ms square by 4 plus ms square by 4 minus 2ms square by 4 cos 60 value 1 by 2. So therefore 2 will be cancelled. So final answer is m by 2. This is 2024 they asked. So net magnetic moment or magnetic moment basing on that till the one concept. Net magnetic moment or magnetic moment. Later time period, later difference between diabar of ferro. So this is about total magnetism will be divided. So theory we won't discuss here, only problems how we are going to solve. That is going to be important. Next, if this magnet is bent, north pole, south pole, it is bent in the form of an arc. In cancelled exam they asked this. So what is the, this is m means, this is m dash. So what is the new magnetic moment means? M dash equal to 2m sin theta by 2 by theta. So this is magnetic moment of arc shape. If reverse, if they bend arc shape into short bar magnet, at the time you require m, then m is equal to m dash theta by 2 sin theta by 2. Now what is m dash? M dash is magnetic moment of arc shape, isn't it? Arc shape to short bar magnet like this, short bar magnet to arc shape. So formula is going to be reversed. So on this how they may ask the questions, we will see some problems. Now see, if resultant magnetic moment south north is there like this. Otherwise they have given like this, south north, south north. So this is closed loop. Always two magnetic moments are in same direction, m1, m2. Blindly we can add one resultant m1 plus m2. If these two are in opposite direction, so m1, m2. So resultant is m1 minus m2. So like this we can follow blindly. Now if you have taken all these are same magnetic moments, then these two are equal and opposite, these two are equal and opposite. Therefore resultant magnetic moment is 0. Not only this one, if you are closing any closed loop like this, south, resultant magnetic moment is 0, like hexagon also. So how many there? South to north, south to north, south to north. If it is closed, south to north. So it is also closed, resultant magnetic moment is going to become 0. If it is not closed, then you have to take care about that. South to north. These two are perpendicular. So perpendicular, however, they have given. So resultant magnetic moment, if it is m and m, so that is going to be root ms square plus m square root 2m square, so root 2 m. So same they have given like this. So m, so m, m. Then what is the resultant magnetic moment? These two are equal and opposite. Therefore, resultant magnetic moment is going to be only this one. M. So already in detail, if you want means we have given 10 minutes videos, 15 minutes videos. In those, you will be getting how it is going to be solved. Same only we are giving, but we are trying to give more information. That's all. South to north, south to north, south to north. All are going to be same. M, M, M. So in this, these two will be cancelled, equal and opposite. So this is opposite, this is opposite. Therefore, m dash is going to be m plus m. That is going to be 2m. Next, one magnet is there, north pole, south pole. If this magnet is cut into two equal parts, then each magnetic moment is m by 2, m by 2. Now they have arranged like this. So one m by 2 like this, another m by 2 in the form of semicircular arc, north pole, what is the magnetic moment of the semicircular arc shape means? So one of the magnet is bent. Now m by 2 is becoming how much magnetic moment means? M dash equal to, what is our formula? 2m sin theta by 2 by theta. 2, what is m here? M by 2. Correct? So m by 2 sin theta by 2 by theta. 2 will be cancelled. M sin, what is the angle here? 90 degrees. Therefore, 180 degrees. Sin pi by 2 by pi. Sin pi by 2 is 1. Therefore, finally you got m by pi. So, this is m dash is going to be m by pi. This m dash is going to be, or m1 is going to be m by 2. How this direction? South north, south north. Therefore, you have to add these two. M by 2 plus m by pi. So same thing they will give. One magnet is going to be given like this. Another one they kept like this. South, north. Now how these two means? Perpendicular. This one is going to be m by pi. Already we discussed. This is going to be m by 2. So net is going to be root of m by 2 whole square plus m by pi whole square. So next, if they gave it some angle, let us assume this is south north. Another one they gave like this, south north. Both are going to be same. It is going to make some angle. So at the time, how we have to solve? So resultant of these two, if those are going to give 30 degrees, let us say, resolve this one into two components. This is m cos 30. This south north will become like this. So this is going to be m sin 30, which is basing theta, that is always cos theta. Now this is m. This is how much? M cos 30. Cos 30 value. So along horizontal, m plus m cos 30. Cos 30 value root 3 by 2 m. Next, this value m sin 30. Sin 30 value 1 by 2. Therefore m by 2. How these two are? Perpendicular. Again you have to find resultant of these two. So m dash is equal to root of m plus root 3 by 2 m whole square plus m by 2 whole square. So this is going to be resultant magnetic moment. You can solve this, then you are going to get the answer. Whenever they give angle, you can try to solve. Like this, you will be getting resultant magnetic moment very easily. Next, we will see some similarities between electric field intensity and magnetic field intensity. If you are taking short bar magnet, north pole, south pole, which is having magnetic moment m. So what is the magnetic field intensity at a distance r? So B on axial is equal to mu naught by 4 pi 2m by r cube on axial line. On equatorial line at some distance r, on equatorial line mu naught by 4 pi m by r cube. If you want vector notation, its direction is in the direction of dipole moment, magnetic dipole moment m. Therefore, south to north. Its direction is opposite to magnetic moment. Therefore, north to south. Therefore, in textbook they will write B equivalent minus mu naught by 4 pi m by r cube. This minus indicates this direction is quite opposite to magnetic moment. Next, at any point which is making some angle theta. This theta should be angle between m bar and r bar. So m bar and r bar. This is theta. So at this point, what is the magnetic field intensity means? At any point mu naught by 4 pi m into root 1 plus 3 cos square theta by r cube. Like this. Next, because of single charge. So south pole or north pole you can take pole strength m, south pole or north pole at some distance r because of the single pole. What is the magnetic field intensity means? Mu naught by 4 pi m by r square. So if you want the single charge at some distance r, what is the electric field intensity means? Kq by r square. What is k? 1 by 4 pi epsilon naught. What is k here means? Mu naught by 4 pi. Like that, the electric potential V is equal to kq by r. Like that, magnetic potential VB, magnetic potential or BV, they are going to write. So k m by r. But you don't have this in our syllabus because monopoles do not exist. But sometimes they may ask, we should be very easy because comparison is going to be available. So where, if you observe one thing, where 1 by 4 pi epsilon naught is coming, there you are going to get mu naught by 4 pi. Therefore, 1 by epsilon naught is equal to where 1 by epsilon naught is coming, there mu naught you will be getting in magnetic field. Epsilon naught is permittivity, epsilon mu naught is permeability. This is about medium allowing how many number of electric field lines. The ability of the medium to allow how many number of magnetic field lines, isn't it? So this is about epsilon naught and mu naught, magnetic field intensity, its directions, still potential energy and time period of the magnet and intensity and all those we will discuss in our next 20 to 25 minutes video. I hope you people understood. If you have any doubts in this, we have given detailed videos in our playlist. You can watch, you can understand. Thank you.